Today the topic is dot product of vectors. Dot product of vectors. Dot product அப்படின்னா என்னன்னு பார்ப்போம். ஸ்கேலார் ப்ராடக்ட் அதாவது டாட் ப்ராடக்ட் அண்ட் ஸ்கேலார் ப்ராடக்ட் ரெண்டுமே சேம் தான். ஸோ ஓகேவா? ஸோ டாட் ப்ராடக்ட் ஆர் ஸ்கேலார் ப்ராடக்ட் ஆர் ஸ்கேலார் ப்ராடக்ட் both are same. Dot product or scalar product. ஓகேவா? Of vectors. Okay. Let us take two vectors. A vector which is equal to consider as 8, 0 and a B vector which is equal to 3, 6. 8 is the first coordinate, 0 is the second coordinate, as well as in the B vector 3 is the first coordinate and 6 is the second coordinate. Okay. What is meant by dot product or scalar product? In two-dimensional space, let O be the origin, horizontal be the x-axis, and vertical be the y-axis. The vectors arise from 0, which is we can take A as this is vector, and we can take this is B vector. The angle between A and B is nothing but theta. Okay. Now the dot product is A vector dot B vector, which is equal to multiplying the first coordinate of A with multiplying the first coordinate of B. The first coordinate is 8, the first coordinate of B is 3, plus multiplying the second coordinate of A vector into multiplying the second coordinate of B vector, which is 6. That is equal to 24. This is one of the method. The another way is A dot B vector is equal to mod of A and modulus of B cos theta. The cos theta is the angle between the vector, between the two vectors A and B. The given angle is theta, which is equal to 63 degree 4 minutes. Okay. Now modulus of A. Modulus of A is nothing but distance from 0, distance from between the point 0 and the point A. This A is nothing but 8, 3. Okay. Distance between 8 and 3. Sorry, 8 and 0. The first vector is A is nothing but 8 and 0. 8 and 0. So square root of 8 square plus 0 square, which is equal to square root of 64 and which is equal to 8. In the same way, we can calculate the B vector. So B vector is nothing but 3 square, square root of 3 square plus 6 square, which is equal to square root of, which is equal to something 9. 3 3s are 9, 6 6 are 36. 6.71. So modulus of A is equal to 8, modulus of B is equal to 6.71. So dot product of A vector into B vector is 8 into 6.71 into cos theta. Cos of theta is 63 degree point 4. So which is equal to 24. In both ways we get the same answer. But in the second method, we need to know the angle between the two vectors. Angle between the two vectors. But in the first method, we does not need the angle between the two vectors. This is the process of dot product. In the same way, the another concept is cross product. Cross product of vectors. Cross product of vectors. What is meant by cross product of vectors? In the dot product, we obtain only the magnitude. Obtain only the magnitude, but not direction. But not direction. We obtain only magnitude, but not direction. But in the cross product, we get direction. But in the cross product, we get direction. We get direction of the vector. Direction of the vector. In cross product, we only opt three-dimensional vectors. We only opt three-dimensional vectors. Why? Because if we cross product the two vectors, cross product the two vectors cross product of two vectors becomes a vector. Becomes a vector which is perpendicular to other two vectors, Okay, example, how this is perpendicular to vectors. Take a plane, just a small plane, the plane name is P, plane. Okay, plane. Take a point on it. From that point O, there is arising of two vectors A and B. This vector is A and this vector is B. And the angle between these two is theta. Now the cross product is nothing but in two ways we can cross product the two vectors. A vector cross B vector, which is equal to in determinant form, which is I j. First row is I vector, j vector and k vector. The second row is nothing but coefficients of a vector. The first coefficient is xii, x1i, y1 j vector, z1 k vector. Next, b vector is x2 I vector plus y2 j vector plus z2 k vector. Then the determinant form of cross product is nothing but first row is ijk, the second row is x1, y1, z1. The third row is x2, y2, and z2. This determinant is the cross product of vectors. The another method is a vector cross b vector, which is equal to modulus of a vector and modulus of b vector sine theta n cap. This n cap is nothing but unit vector. Unit vector is, this is the unit vector. N vector, n cap or n vector is nothing but I vector plus j vector plus k vector. All the coefficients are 1. That's why it is called unit vector. The whole form of cross product is nothing but take the two vectors A and B, we get A cross B as perpendicular to the both vectors 90° and 90°. This is the A cross B. That is, in the plane, we get the A cross B as perpendicular to A and B. This is the A cross B. This is the A cross B. This is 90° and this is 90°. This is also 90 and this is also 90°. Okay, wow. Next is modulus of A cross B. Modulus of A cross B. Modulus of A cross B means modulus of A modulus of B sine theta whole thing modulus, which is equal to area of plane formed by joining the vectors, joining the vectors A and B. How? Now take take a plane, take a plane. In that plane, there is a vector A. There is another vector B. The A cross B becomes perpendicular to the both vectors. This is A cross B. This A cross B, take the modulus of A cross B. This is equal to what? This is equal to, the point is origin point is O. The meeting point is C. Area of this is A cross B. Area of OABC. Area of OABC. This is the main concept of the cross product of vectors. How to apply this concept in differential geometry? In differential geometry, in differential geometry, the main vectors are the main vectors are T, N, B. T is tangent at the point. N is normal at that point. B is binormal. Where take a three-dimensional space. X, Y, and Z. X, Y, and Z. Okay. Now take a curve. P, Q. This curve is called space curve. This curve is called space curve in three-dimensional geometry. Now take a point O. Take a point O. Now draw a tangent to the point O. This is T. Now draw a normal to O. This is N. Now draw a binormal to O. This is B. A cross product of T cross N, which gives B. Cross product of B cross N, which gives T. Cross product of T cross B, which gives F. This is the main concept in differential geometry. This is the main concept in differential geometry. There is another concept is we can now find the angle between the three vectors. These angles are always what? 90 degree. These are angles are always 90 degree. Each is perpendicular to one another. Now cross product of two vectors is 0. When the cross product of 0 only happens, the two vectors are parallel. For only happen for two vectors are parallel. In the dot product, if it is 0, only happen for two vectors perpendicular to each other. Two vectors perpendicular to each other. Perpendicular to each other. That's all.